In this chapter, we're going to be going over annual worth analysis. This is very similar to the previous chapter, but here we are going to see that annual worth analysis, AW analysis, has some advantages over PW, and it will make it much easier on us to solve some questions. If you recall, in the previous chapter, which which was about PW, usually take into consideration the LCM. So when I have a different LCM, I have a problem. Therefore, I have to use LCM in order to get the two alternatives within the same life cycle. So if I take a look at machine A and machine B, this is 3 years, the life cycle of it, and this one is 6 years. And this is a problem for PW because, within this 3 years, okay, I'm gonna buy a new one, while I'm gonna buy a new machine after 6 years. So it is not fair to compare them this way. That's why we use LCM, okay? This is in PW, that was in chapter 5. In AW, I don't have to deal with this problem, okay? I don't have to deal with LCM. And by that, I can, assure you that every cycle, whether you repeat it once, twice, thrice, or more, is going to lead to the same result. It's going to make us select the same alternative. Let's take a look at some examples so we understand what's happening here. Okay, if I go back, to this example, let's solve it, the old way. I have a machine, it's gonna cost, actually it costs $20,000, and the annual operating is $8,000. So $8,000, it's annual. That means it's $8,000 per year. That's an A, okay? And the first cost, its initial cost, we call it present value. So this is P, this is now A. Salvage value is the money that you can get once you sell your old machine after the life cycle ends, and therefore it's in the future. So this $5,000 is in the future. How many years? You are gonna sell this after 3 years. They're telling us calculate AW, okay, for 1 cycle and 2 life cycles. 1 cycle, that means 3 years. 2 life cycles, that means 6 years. In other words, it's like, as we did in PW. If I have a machine within 3 years and a machine within 6 years, I have to find the least common multiple, back to here, if you want to take a look at it. Okay, what did we do? We found the least common multiple between 3 and 6. It is 6, as we discussed before. So here, let's assume we want to use, and LCM, okay, back to here. When I tell you, hey, 3 and 6, the LCM is 6, that means the first cycle here, I have to extend it to another 3 years. So I have 2 cycles. Okay, the first 3 years, then the second 3 years. And that's why on the 3rd year, what did we do? We buy another one and sell the old one, as you remember. And this is only 1 cycle. So now we are assuming here the same. You know what? I'm gonna, solve this, question. And I want to see how much I'm paying within a year. Within 1 life cycle. And then I'm gonna solve for it and get the AW within 2 life cycles. And I want to see whether there is a difference or not. To solve for AW, basically what I'm doing, I am taking all these values I'm paying into the domain of annual, payments. Okay? So the present worth, it's in the present, it is now. Okay, how much, the money now, how much the money now is going to be, equivalent to per year. So therefore, I have to use the notation that convert the present worth into annual payment. And that's why we have a P to A. I want to transfer the amount from present worth to annual worth. Why to annual worth? Because I want it in annual worth, factor or domain. Okay. $8,000, it's already per year, so I keep it. I don't have to convert it to any. It's it's in the proper domain that I'm checking, right now. Future, $5,000 salvage value, it's a future. So therefore, I have to transfer the F value, okay, the value in the future into the value of yearly, equivalent. So that's why the $5,000 in the future, I have to transfer it into A. The interest is given, okay, and and the number of years is 3 years. Why? Because they wanted one cycle. We go back to the table, we can get the value of this, and we go back to the table, we can, by the end of the book, and we can find the value of this. And you can check the previous, YouTube to see how we did it. So the value was around negative $4,500. Now, if I do it for 2 life cycles, it's going to be the same amount. If I do it to the third, annual worth at, within the 3 life cycles, also is going to be the same. How did they do this? Back to here. Okay. The first cycle, I had to buy the machine. So how much is it? $20,000. And I have to transfer it from present to, to 20,000. Why we have here 6? Because I'm assuming it's gonna last for 2 cycles. So it is 6 because I want to see the equivalent of this $20,000 that I pay now per year, and how many years I need. My annual worth analysis is for 6 years because it is 2 cycles. They ask for here 2 life cycles, so it is 6 years, 3 and 3. So that's why it is 6. So in other words, I'm saying I want it from 0 to 6. This is my first life cycle. This is my second life cycle. Okay, so I go back to here. This is $8,000. Why nothing is change here? Because every year I'm paying $8,000. Whether this or the we said A, it's always consecutive, same period, same amount. So therefore it's gonna be the same, and it is in A domain anyway. So I need everything to be in A. And this is in A, okay? That means annual. So we are good. While P, this is $20,000. This $20,000 is P, is the money now. I want to transfer it into another domain, which is the annual worth. I want it to be per year. For how long? For 6 years. That means year 1, 2, 3, 4, 5, 6. Why 6 years? Because they requested this, okay? Here they requested 3, okay? I put 3. Interest is given. Now back. Why this is negative? This is negative because I'm paying. I'm losing money. So if I want to draw the flow chart diagram, I should have here an arrow, okay, going as you see, downward. Back to the 15,000. Okay, this here, just forget about it for a second, and let's go to the last portion. What's this $5,000? It's the salvage value. But it is after 6 years. So at year 6, I'm going to have a salvage value of that machine. I'm going to sell that machine for how much? For $5,000. So that's why I have 6 years here, okay? Now, where did we get this one here? This, if you remember from previous, chapters, guys. This $15,000, because, where I get it from? Because I have two life cycles, the machine typically lasts for how long? It lasts only for one life cycle, which is 3 years. 1, 2, 3. I'm extending this. I want to have the study for 2 life cycles. Therefore, at year 3, the machine is dead. Okay? I have to sell it rather than throwing it away. I sell it. How much is gonna cost? How much is gonna, get me? It's gonna get me $5,000. Okay, this is a salvage value. So this is $5,000 here. Then in order to continue with the next life cycle, I have to buy a similar machine. How much is the same machine? A similar machine? Also $20,000. This is the way we do it. This is our assumption. Okay, always we use such kind of assumptions in such chapters. Okay, so in order to have another life cycle, I assume it is the same amount, present worth, and same annual worth, and same salvage value. So I repeat everything. So now at year 3, I already made $5,000 from the previous machine. Then I bought a new one. $5,000 of profit, $20,000 loss. So we have here negative 15. Okay? So that's why here I put negative 15. But what's this AP6? Because this here is gonna be for how many years? We said for 6 years. So I want to have those 2 life cycles for 6 years. Okay, for 6 years. Okay, one more thing here. Where I get this 3 from? This is also straightforward, because at year 3 here I had a salvage value, isn't it? Yeah, that's what we studied in shifting. Okay, so I have to shift now this. Okay, 3 years. I have to shift it 3 years. So we go back to this again. Be careful for this simple trick. Okay, we're gonna do it once. Later on, there is no need to do it. We are here just proving our concept that whether you do AW for one life cycle or 2 is the same. And that's why we're gonna see there is no need to do this anymore, this here. Okay, we can always do it once and we are happy. No need to use second life, okay, to make up, same LCM. But, for the sake of argument, okay, let's prove it. So at year 3, I have to have another life cycle. At year 3, I have to sell, as I said, and buy. So it is negative 15,000. Okay, so now I have here an amount. This amount is how much? Negative 15,000. 5,000 minus 20, negative 15,000. Where I want this money, to go to? I want to find the equivalent of that money in what? In, A domain. That means I want to know the equivalent of my money at year 3, okay, per year, how much it would be. So I want to get this money for how many years? We said our annual worth analysis is 6. So I have to distribute this amount into 6 payments, taking into consideration what? The interest rate, okay? So that's why I cannot just say, hey, you know what? It's $15,000 and divided by 6. No. You have to take into consideration what? The interest rate. And another thing, this money here, okay, if I want it, okay, this money here, it is in what? It is in the future. Okay, it's in future. So what they did in this typically, look how simple it is. So you don't have to forget it. They said, you know what? I have my money here in the future. Okay. After, after I paid attention, hey, it is in the future, let me take it from the future to the present worth. Okay? So they took this amount from the future, because this is the future with respect to present worth, the first present worth. So negative 15 here is what? Is $15,000. Okay, they said, let's take it into present worth, transfer it into present worth domain. Okay, so they are telling us, let's find the equivalent of this money where? In the present worth domain. How do we do it? Basically, it is, simple equation. If you go back to our, friend here, okay, we said if I want to transfer anything from the future to the present, what do? I will say, hey, present worth is what is equal to, okay, the amount in the future, and then transfer it from the future to the present using what? Using this notation. That's it, isn't it? So I took this $15,000 and I transfer it into P. Then I said, you know what? I don't want it in P. Okay, I need it in exactly. It's annual. Okay, it's annual. So how I'm gonna transfer my money from the present into annual? They said, okay, let's assume. Okay, this is I don't know how much is it. They don't show it to us. But anyway, let's assume this is an X amount. So let's call it X. Okay, let's call this equal X. Good. So if I have X money here, how I'm gonna transfer it from P domain into A domain? Oh, this is also easy. How do we do it? We can do it as follows. Okay. We say take X, okay, which is the the present worth. How much is A? It is X multiplied by, this notation, transferring the P to A. P is the X value here, isn't it? But this is a notation. It's not a value. Anyway, so by that, what I'm getting, this notation. Okay? So if you get confused, just remember the following. At year 3, I have to sell and buy another one in order to have a new cycle. This money here, when I sell and buy, it's negative 15. Send it to the present. Then, from the present, convert it or transfer it to yearly payment using this formula. Okay? As simple as that. And guess what? It's the same amount. So what we say, rather than using, 2 cycles or 3 cycles, once you get AW for 1 cycle, any other cycle, it would be the same. And by that, this is one of the advantages of using AW, over PW. So let's move to another simple topic, which we call it capital recovery. Okay, capital recovery. You paid some money. Now I have to recover my money. I need to recover my money. So the first question would be, hey, you want to recover it per amount without a need of interest rate. So you get just, net, you just get your payments. Okay. Or no, tell me, no. There is, value of money involved. So I need, to include the interest rate. Okay. So this is typically here we use the interest rate. Okay, we use the interest rate. So the capital recovery, CR, is the equivalent annual amount that an asset, process, or system must earn each year to just recover the first cost and a stated rate of return over if it's expected life. Okay, so what I'm saying here I have money, okay? I bought an asset with that money. Let's say I opened a business. So I want to know how much money I can recover. So if I paid for that system, shop, process, anything. Let's say I bought, I paid for it $20,000. I have to know, okay, what is the equivalent annual amount, I'm getting out of that business. Okay, that's what we call it recovery. Recovering my money. That means I'm getting my money back. Okay, and we are doing it for what? To just recover the first cost. But I include with it what? Interest rate, because we said money has value with respect to time. But how long I'm gonna get this money? How long it's gonna take me to recover the money? You have to keep in mind it has to be within what? The life cycle. Okay, that I'm expecting. So capital recovery, what it is? Basically, it is my cost, my initial cost, as we said, my first cost, the money I paid now, okay? And how much this money would be, per year. So basically, I am converting the money that I'm paying now, how much it would be, equivalent to per year. Another example, maybe you can get it easier, just to simplify the idea. You go to the bank, you deposit your big amount of money in the bank, okay? And then you ask your bank, hey, how much this money would be equal to every year, including the interest rate, because the bank is gonna pay you interest rate on the money per year, let's say. So you would like to know how much your payment per year, okay? So you are looking for your profit here. But my point is this: you are paying attention to two things. You have a present worth, the money you are paying now, and you want to know how much is it per year. Per year here is the annual, okay, is the annual. Now, same thing here. I paid money to open, let's say, a small business. I want to know that money, let's say $20,000, how much it would be equal, okay, how much I can recover, okay, as percentage-wise per year, including what? Interest rate. So let's say if I don't want to use any interest rate, let's say, hey, I paid the $20,000 for a specific machine, making certain products. So this machine, when I started it, it cost me $20,000, and based on my analysis, is gonna deliver for me every year, $1,000. What's the life cycle of that machine? 20. So how long is gonna take me to get my first cost? 20 years, because $1,000 every year, okay? Within the 20 years, I'm gonna get $20,000. But where is the problem with this kind of analysis? It's very primitive. Why? Because I'm not taking into consideration the interest rate, and I'm not taking into consideration the salvage value, because maybe after 20 years I can sell that machine, for $5,000. So this is the proper way we do it, based on the concept that money has value with respect to time, which is very simple. Just give me the amount. How much is the amount you paid for? I paid the $20,000. Perfect. Now I have to transfer it from the now domain, the present domain, into a domain, because I want to know how much I'm paying. Then, is there any salvage value? If there is, also you have to transfer it from the future also to A, because salvage is the future. And guess what? Should be the same interest rate and same, number of years, at least in our, chapter. And that's what happened here. We have $20,000. Voila, as simple as that. So what do I call this? I call it capital recovery. Capital recovery. Why this is negative? Because this is a money I paid and I need to recover, okay? I paid the $20,000, so it's negative. Why this one is positive? Because this is a money I'm gonna make in the future after I sell my machine, salvage value. Okay, after I get the capital recovery, now I ask myself, hey, you know what? What's the total? Okay, I'm paying, every year based on this. If I pay $20,000, as a first cost, that means I'm paying $6,532 per year. And this, what does it include? It does include the interest rate plus the salvage value. Where they are now embedded here. They are embedded in this amount. So this amount, what does it represent? Represent all the money. That means the money now and the money I'm gonna make in the future because of the salvage value, and I transfer them to A domain, okay, which is the annual per year. This is my payment per year. If there is any extra payment, then I have to add it. So here they have $8,000. What's this $8,000? They consider it maintenance, okay? So now I know, hey, I have to pay, every year $14,000. So that means it is the payment of the machine per year and the maintenance. So in a nutshell, what I'm saying, I bought a machine, okay? Or I'm thinking about buying a machine. They are telling me this machine is gonna cost you $20,000. To me, I don't understand this. Give me, please, the payments in year domain, okay? Because I'm not gonna pay right away $20,000 for you. Let's assume the following, okay? So what you are gonna do, you are gonna tell me, okay, we can say, hey, if you pay $20,000 now, okay, if I wanna transfer it into yearly payment, then the machine after 3 years, you can sell it for how much? $5,000. After it is dead, you can sell it, okay? You make $5,000. So you are gonna be paying per year this much, okay? And then the guy is gonna tell you, hey, also there is maintenance year per year. So this is your total amount. Okay, perfect. Okay. So this is how I can get the money into, year domain, but as a recovery way here. Okay. I need to recover my first cost, but I need to know how much is it per year, how much I'm gonna recover per year. Okay. So this is very straightforward. Now we go to the second one. Okay. For the second one, we are saying, hey, we have a mutual exclusive. You remember from the present worth, if we have a mutual exclusive and they are in different life cycles, we have a problem. We have to use LCM. So this system, the first system here, the life cycle is 4 years. I mean the life of this is 4 years, and this is 6 years. Okay. So we used to get the LCM. We're gonna say, hey, what's the LCM between 4 and 6? We're gonna say 4, then 8, then 12, and 6 will be 6 plus 6 will be 12. So I have to have here, several life cycles, and here I will have 2 life cycles in order to solve it. If I'm using AW, I don't have to worry about how many life cycles. I just say, hey, you know what? Get me the AW of this. And the AW is per the cycle given. What's the cycle here? 4. Okay, good enough. No need to do LCM. And then the second machine, how much is it per year? for the whole life cycle, okay, you do it. So keep in mind, guys, I'm dealing with life cycle, within the range of the years. Okay, how many years here? 4 years. That's why it is 4 years. Okay, but I want to know those values in a domain. Okay, in a domain. Okay, that's why we call it annual worth. So it is a life cycle of 4 years, but how much is it per year within the 4 years? So the interval is 4 years. Okay, the interval is 4 years, but I want it what? In a domain. Okay, that's why everything into a domain. So I'm getting all my payments per year. What's the interval? 4 years. And this is what we call life cycle. Okay. What about the second machine? Also the same thing. The interval is 6 years. So I want to know all my, I want to convert all my payments, including salvage value, maintenance fees, present worth, all these payments. I want to transfer them, okay, every one of them into what? Into a domain, okay? For how long? For 6 years. So I have, payments every year, but the interval is for how long? 6 years. Did I use LCM? No, because here it's 4 and here it's 6. So I solve this. We have the $30,000. I paid for it. It's a present worth converted from P to A. 18,000, it's already in A because it's per year. 7,000 is in the future. You transfer it from F to A, and I'm done. Same thing with this one. Now, because they told me it is ME, okay, ME alternative. They are ME alternatives. What does it mean? Mutually exclusive. So I have to select only one project. How? As we said before, we select numerically larger value. So if both are negative, I choose the one closer, to 0. So between negative 26 and negative 27, to me, I would rather, save $1,000 and get what? Negative 26. Because to me, negative 27, that means I'm paying more money. It's not good for me. If it were to be both are positive, for sure I will choose the higher amount, okay? So that's why we call it a numerically larger value. So if both negative, I will select less damage. If it is, if they were to be more both positive, I will select, the higher positive value. Keep in mind, this is if we have couple to choose from. Let's say I have only one project. If I have only one project, okay, no other alternative, I check if it's greater or equal to 0. That means it's good. Okay, what does it mean? That means my payments per year, they are positive. I'm not paying, I'm making money. Okay, so it's a profit, it's a revenue. It's good for me. Okay, if it is negative, it's a problem. This is if it is only one alternative. That means I don't have another alternative. It's not a mutually exclusive. It is only one project. Okay, like independent project. Anyway, back to another question here, and this is the last one. What if I have two alternatives? One of them is, the life cycle of it's infinity, long-term project, like government project, maybe 40 years, okay, to finish, 50 years to finish. So here we say it is infinite life cycle. So the alternative here, it is infinite alternative. How we solve it? We did something similar to this in the PW, okay? And we are going to repeat it here. Look at this. We need to get what? We need to get AW, okay? So we have this alternative. This is, we know it is P. So I transfer P into A. So this is 50,000. We use this notation to go from P to A, and then we go to the table, we'll find the value here. Negative 20,000, it's already annual. So it's annual, and I need everything to be in A. That means per year, okay? Equivalent to, yearly payment. So this is happy. Same domain, same unit. What about 5,000? It's salvage value. Salvage value, it's in the future. So I transferred from F to A. Okay, I got what? AW. For the infinite alternative, because it's infinite, I cannot apply, all these formulas. So what do? I say, hey, you remember from the previous session, we said I'm sorry, okay, here. We said, P equal A, divided by I. You remember this? What did we call this? Capital cost back then. When we want to do the capital cost for the infinite alternative, we use this. Now here, they are reminding us about it. Okay? Back to this here. If P equal A divided by I, so what does it mean? That means what? A equal to P multiplied by I. Okay? From algebra. Okay, good. So this is A equal P multiplied by I, and that's what they used. They said, hey, get me the present worth because it is infinite. Don't do this, okay? Don't do this. So because it's infinite and it's unknown, you cannot go to the table and get it. It's infinity. So just use P times I. Okay, how much is P? Negative 250 multiplied by I, which is 10%. And then the other one is what? $9,000. It is in year. So, okay, you keep it in year. And because everything is in year. Okay? What about the salvage value? We said, when we have infinite alternative from previous session, we do not include what? The salvage value. And here we go. Now, this is negative 32. And this is negative 34, about negative 32 and negative 34,000. We said we choose less negative if both are negative. 32 is less damage. If it were to be positive and this it were to be positive, then I choose the higher positive. But here we have both are negative, so we choose the less negative. This is it for AW. I hope you enjoyed this session. Take care. Bye.